Look at this. Off the US coast, there are massive oil tankers just sitting there. These aren't small ships. They're giants, about 1,000 feet long, able to carry roughly 2 million barrels of oil in a single trip. They're built to move crude around the world, but right now, a lot of them are sitting almost empty. Nearby, you've got terminals, cranes, full infrastructure. Everything is ready to load. At the same time, the US is sitting on millions of tons of oil, not in one place, all across the country, in storage tanks, reserves, even underground caverns. At certain times, these stockpiles reach hundreds of millions of barrels. For example, the US Strategic Petroleum Reserve has held over 700 million barrels at its peak. Commercial inventories regularly sit above 400 to 500 million barrels. So the situation looks strange. The oil is there, the tankers are there, global demand is there, but none of it connects. Meanwhile, the US is one of the largest oil producers in the world. After the shale boom, production climbed to over 12 to 13 million barrels per day, more than most countries. And yet, tankers sit idle. Oil builds up. And sometimes, something even stranger happens. The US keeps importing oil from other countries. So the question is simple. If a country has oil and has tankers, why can't it just load it, ship it out, and make money? At first, it seems obvious. You've got three things: oil, transportation, and buyers. Connect them, and it should work. But once you dig into it, each part is more complicated than it looks. First, oil isn't a finished product. It's raw material, and it varies in composition, density, and sulfur content. Different types of crude behave differently during refining. You can't just mix everything together and treat it the same. Second, a tanker isn't something that can just pick up oil from anywhere. It only works where there are proper ports, enough depth, and the right infrastructure. And most importantly, where the oil can actually reach it. Third, the oil market isn't just there's demand, so ship oil anywhere. It's a global system built on contracts, pricing, logistics, and constraints. Sometimes, it's cheaper to buy oil from another country than to move your own. And that's where the paradox shows up. The system looks simple, but it doesn't work as one piece. It's split into parts, and each one limits the others. On top of that, most of the extra oil isn't where the tankers are. The main production regions in the US are inland. The biggest one is the Permian Basin in Texas and New Mexico, one of the most productive oil regions in the world, producing millions of barrels per day. Another major region is the Bakken in North Dakota. That's also inland, far from the ocean. If you look at a map, it's obvious. Oil is produced deep inside the country, while tankers sit along the coasts, the Gulf of Mexico, the East Coast, the West Coast. Between them are thousands of miles. And that distance isn't just geography, it's the core problem. Production in the Permian Basin grew extremely fast, faster than infrastructure could keep up. In some years, output increased by millions of barrels per day. But pipelines, terminals, and ports don't get built that quickly. So oil starts piling up locally, in storage tanks, in reserves, right near where it's produced. Sometimes, you end up with too much oil in one region and not enough where it's actually needed. So yes, the oil exists, but not where it can be loaded onto tankers. So why not just move it? Because the main way to move oil inside the US is pipelines. Not trucks, not trains, pipelines. That's the only way to move millions of barrels per day. But pipelines have limits. Every line has a maximum capacity. When production grows faster than new pipelines are built, the system gets overloaded. This has happened in the Permian Basin several times. At certain points, pipelines were so full that there was literally nowhere to send the oil. As a result, local prices dropped tens of dollars below global benchmarks. Not because the oil was bad, but because it couldn't be moved. New pipelines take years to build. These are complex projects that require permits, massive investment, and often face political and environmental opposition. Some projects get delayed or canceled. Legal battles and protests around oil infrastructure are common in the US. So what you get is this: oil gets stuck before it even reaches a port. It might seem like there's an easy workaround. If pipelines are full, why not move oil by water within the country, ship it from one US port to another, then load it onto international tankers? This is where one of the most unexpected factors comes in: The Jones Act. This law has been in place since 1920 and regulates shipping between U.S. ports. It requires that all domestic shipments be carried on ships that are built in the U.S., owned by U.S. companies, fly the U.S. flag, and are crewed by American workers. The problem is, there aren't many of those ships, and they're much more expensive than international vessels. In some cases, shipping oil within the U.S. costs several times more than shipping the same oil across an ocean. This leads to one of the strangest outcomes. Sometimes it's actually cheaper for the U.S. to import oil from another country than to move its own oil domestically. These are real situations that have happened multiple times. Oil from Canada or the Middle East can reach refineries faster and cheaper than oil from Texas. That completely breaks the logic. A country with excess oil ends up buying oil from abroad. And even if you solve the logistics problem and get the oil where it needs to go, there's another issue: the oil itself. The shale boom in the U.S. produced huge amounts of what's called light crude oil. It's less dense, has lower sulfur content, and is easier to refine into certain products. But historically, U.S. refineries were built to process heavy crude, thicker, higher sulfur oil. That heavier oil has traditionally been imported from places like Venezuela, Mexico, and Canada. Refineries are designed around it: their equipment, processes, everything. When U.S. production of light oil surged, the system wasn't ready for it. Refineries can't just switch overnight. It takes billions of dollars and years of upgrades. So another mismatch appears. The oil exists, but it doesn't fit the existing refining system. Some of the light oil gets exported, some gets blended, some gets refined in limited ways, but you can't fully load the system with it. When you put all of this together, it becomes clear the problem isn't just one thing. It's a chain of constraints, where each piece blocks the next. Oil is produced in the wrong place. Transportation can't keep up. Laws make logistics more expensive. And the oil itself doesn't always match refining capacity. That's why you get this strange picture: tankers sitting empty while oil is piling up. The system just can't connect the pieces. But that's still not the whole story. Let's say the oil actually makes it through the hardest part. It leaves the Permian Basin, goes through overloaded pipelines, and reaches the Gulf Coast, right where the tankers are. You'd expect things to finally get simple here. There's a port, there's oil, there's a ship, just load it. But this is where another problem shows up that most people don't think about: the ports themselves. Not all ports can handle large tankers. And this isn't a minor issue. It's a physical limit: water depth. The largest oil tankers in the world can carry around 2 million barrels per trip. But when they're fully loaded, they sit deep in the water, up to about 65 to 72 feet of draft. And here's the key point: most U.S. ports aren't that deep. Major export terminals along the Gulf Coast, in Texas and Louisiana, have long been around 40 to 50 feet deep. That's enough for mid-size vessels, but not for fully loaded supertankers. So what happens in practice is simple. Even if oil reaches the port, you can't just load it onto the biggest and most efficient tanker. Instead, a workaround is used. First, oil is loaded onto smaller ships. Those ships go out into open water. There, they meet a larger tanker waiting offshore. Then comes a ship-to-ship transfer. Two massive vessels sit side by side in the ocean, connected by hoses, pumping oil from one to the other. But this isn't just more complicated, it's more expensive and riskier. Every transfer adds costs: another vessel, more crew, extra insurance, and the risk of spills. Weather can delay or disrupt everything. And maybe most importantly, it takes time. While the oil is being transferred, the tanker isn't moving. It's not making money. That lowers the efficiency of the whole system. Even the biggest export hubs in the U.S. have limits. For example, the Houston area, one of the busiest in the country, can handle huge volumes, but not unlimited amounts. In recent years, U.S. crude exports have reached over 3 to 4 million barrels per day, but further growth runs into infrastructure limits. Some projects try to solve this. Deepwater terminals in the Gulf allow large tankers to load directly. One example is the Louisiana offshore oil port. which can handle very large tankers without offshore transfers. But there aren't many of these facilities, and they don't cover the full volume. So even when oil reaches the coast, it still can't always be loaded efficiently. So yeah, infrastructure can't keep up with production. But then an even stranger factor kicks in: economics. The price of oil isn't just how much a barrel costs. It's a global system shaped by dozens of factors: transportation, demand, oil quality, distance, contracts. Right now, there are two main benchmarks: Brent crude oil and West Texas Intermediate, and there's almost always a gap between them. For example, WTI can trade $5 to $10 per barrel cheaper than Brent. Sometimes the gap gets even bigger, and that difference is directly tied to logistics. When there's too much oil inside the US and it's hard to move, the local price drops. Not because the oil is worse, but because it can't get to where it's needed fast enough. And that's where the paradox starts. Say you've got oil in Texas selling for $70 a barrel, and oil on the global market going for $80. It sounds obvious: use your own oil. But if it costs $15 per barrel to move it where it needs to go, while imported oil only costs $5 to deliver, imports end up cheaper. And that's what companies choose. It sounds absurd, but it's just how the market works. Companies don't care where the oil comes from. They care about total cost. So you get this strange situation where the US can export oil and import it at the same time. For example, light crude gets exported because it's in demand in Europe or Asia. Meanwhile, heavier crude is imported because it works better in US refineries. It looks like a contradiction, but it's really just of a complicated system. But there are moments when this system doesn't just struggle, it completely breaks down. The clearest example is the 2020 crisis during the COVID-19 pandemic. When lockdowns started, demand for oil collapsed. People stopped driving, planes stopped flying, factories shut down. Oil consumption dropped by tens of millions of barrels per day. But production didn't stop right away. You can't just turn off oil wells like a light switch. It's a complex process that can damage equipment and reduce future output. So oil kept flowing into the system, but no one needed it. Storage started filling up fast. One of the key hubs, Cushing, Oklahoma, was getting close to capacity. This is a major storage point and the delivery hub for WTI pricing. As storage filled up, something happened that had never really been seen before. In April 2020, WTI prices went negative, dropping to around minus $37 per barrel. That means sellers were paying buyers to take the oil. The reason was simple: there was nowhere left to store it. And this is where tankers suddenly took on a new role. They started being used as floating storage. Companies weren't renting tankers to move oil. They were renting them to store it out at sea. At peak moments, dozens of supertankers were just sitting offshore, full of oil, waiting. But even that had limits. There are only so many tankers. Charter rates go up, and once again, it all comes back to economics. That moment exposed something important. The oil system can't adapt quickly to sudden shocks. When demand drops, production doesn't stop instantly. When there's too much oil, you can't just remove it overnight. When infrastructure is overloaded, everything starts breaking at once. This isn't a flexible system. It's a heavy machine that only works within a certain range. And once it moves outside that range, things get chaotic. Now, if you put everything together, it becomes clear why the idea of just load the tankers doesn't work. The problem isn't in one place, it's a chain. First, the oil isn't where it needs to be. Then, it can't be moved fast enough because of pipeline limits. Then, laws like the Jones Act make domestic shipping expensive. Then you run into the issue that the oil itself doesn't always fit the refining system. Ports can't handle the largest tankers. And in the end, everything runs into economics, which can make any step unprofitable. Every stage adds its own constraint. And the key thing is, they don't cancel each other out. They stack. So the system doesn't work as one connected whole. It works like separate pieces that aren't fully in sync. The US is often seen as an energy superpower, a country producing millions of barrels of oil every day, shaping global markets. But inside that system, there isn't total freedom. So you end up with this strange reality: massive tankers sitting offshore waiting to be loaded, while millions of tons of oil sit inside the country. And the two never fully connect. That's just how the system is built.